Problem 8.13, given that the square root of 1 plus x can be written as 1 plus x over 2 plus small of x when x goes to 0, prove these two, the first limit and the convergence of the series. Okay, so this problem is again another example of the power of these Taylor approximations, how we can use them to prove a lot of things in other areas of math. Okay, so the first thing is we have the limit when n goes to infinity of the sine of pi times 1 plus n squared, right? Now we know that the approximation of 1 plus x, and here we want x maybe n squared, this is good when n goes to 0 or x goes to 0 here, right? But here in this case we have n goes to infinity, so how can we transform this? And this is, I guess, the only difficult part of this problem. Well, we can multiply and divide by n, right? And then we have, this is n, and this goes inside as the square root of n squared. We divide here, and so this is the square root of n, 1 plus 1 over n squared. And now here, this 1 over n squared goes to 0, so we can approximate this using this. So we have the limit when n goes to infinity of the sine, and then we have n times pi times this. Let me write it here, 1 plus 1 over n squared. And now we can approximate the square root with the Taylor expansion here. So this is 1 plus, and you have x over 2. X here is 1 over n squared, so this is 1 over 2n squared. And then we have plus small o of 1 over n squared, right? And that's it, right? Now here you can see here what you get is the limit when n goes to infinity of the sine of n pi plus, and then we have 1 over 2n plus small o, sorry, pi over 2n, yes, plus small o of 1 over n, right? And let me write it like this. So now we have, this is the sine of the sum, so we can use the formula for the sine of the sum, and this is the sine of n times pi times the cosine of the second thing, so pi over 2n plus small o of 1 over n, plus, and then we have the cosine of n times pi times the sine of pi over 2n plus small o of 1 over n. This is what we have. Okay, this is the whole limit. Now this thing, the sine of n times pi is 0, so this first thing is equal to 0. So what we have is, this is the limit when n goes to infinity of the cosine of n times pi, which is minus 1 to the n, right, times the sine of pi over 2n plus small o of 1 over n. Now when n goes to infinity, this thing goes to 0, and so the limit of this is minus 1 to the n times 0, so this is 0. Okay? Now for the second one, let me have this here before I erase it. We have this, the sum from n equals 0 to infinity of the sine squared of pi times the square root of 1 plus n squared, but we have just written that this is equal to this, so this is, let me write it here. This is the sum from n equals 0 to infinity of the sine squared of n pi plus pi over 2n plus small o of 1 over n. Okay, that's the sum. Okay. And wait a minute. So yes, okay, so yes, that's correct. But we, yeah, sorry, yes. So we have seen that this is equal, this is the sine of n pi plus pi over 2n plus small o of 1 over n, all of this squared. But we have seen that this, using the sine, the formula for the sum, we have this is the sine of n pi times the cosine of this, and then we have the cosine of n pi, so this is equal to minus 1 to the n times the sine of pi over n over 2n plus small of 1 over n, all of this squared. Okay, so let me write it here. So this is the sum from n equals 0 to infinity of, and then minus 1 to the n to the square, this is 1. So you have the sine squared of pi over 2n plus small of 1 over n. Okay. And now what we have here, this the sine squared, we know that the sine of whatever, sine of x is x plus small o of x, right? So this sinus squared is going to be x squared plus small o of x squared, right? And so in this case what we have is the sum from n equals 0 to infinity of, and then we have x squared, which is pi squared over 2n squared plus small o of 1 over n squared, right? This is what we have using Taylor's expansions, right? And so this is like two sums if you want, but this is the generalized harmonic series with n squared, right? This is just a multiple of, it's alpha times this, right? And we know that this is convergent, and this particular sum is even smaller, right? So all of this is approximately equivalent to this, so all of this is convergent.